So we have a new section. This is going to be 5.6. 5.6 has to do with multiplying polynomials. So we learn how to add and subtract. We also learn what a definition of a polynomial is. If you remember, the word polynomial just means many terms. Terms are separated by addition and subtraction symbols. So we're going to be multiplying, like in this case, mononomial. Notice there's no addition or subtraction in this set of parentheses. It has one term. Times a trinomial. 1, 2, 3. See how these subtractions separate these two terms, and this subtraction separates these two terms? So you have a mononomial times a trinomial. When we're multiplying polynomials, it's different than the addition and subtraction rules. Remember, if this was like plus this and this, or subtract this and this, remember how we would say put in understood ones, distribute, and get rid of the parentheses. Here, because there's no addition or subtraction, just two parentheses next to each other, we cannot distribute the outside ones here. We're going to do a different method. Now, there are actually 3 different types of methods out there to do multiplication. There's a distributing method, but I'll explain that this is much different than the addition and subtraction guide. There's the FOIL method. It stands for first, outer, inner, last. But that only works if you have a binomial times a binomial. So I know a lot of people have heard of FOIL, and I hate to say, I don't like FOIL at all because it's limiting. You can only use it on certain problems. The third type is the rectangular method. This one I actually prefer out of all of them. Distributing is not bad, but it's not as organized. It's a little chaotic, so you might lose a piece. While the rectangle method is more organized. So that's why I like this method compared to these other methods. Okay. So let's talk about the distributive method, just in case you're that person who likes it. The distributive method is saying that whatever is in this first set of parentheses, you have to distribute to each term inside the parentheses. So we're not adding an additional outside one. We're taking this set of parentheses and distributing to each term in here. So we're doing this with this, this with this, this with this. So when you're distributing, you're multiplying. So you're just basically doing negative 6k times k squared. And doing negative 6k and multiplying with the negative 11k. And doing the negative 6k. See how I'm just distributing this to each of the terms? Now, once we have this written out, we're going to actually have to use what we call the product rule. This looks like the product rule, guys. Remember, you have like bases. When you have like bases, you keep the same base, but add the exponents, and then multiply any coefficients that they might have. So each one of these is technically the product rule. And that's why we learned the product rule first. So let's talk about how to do this. If you don't see an exponent, remember how many times I said there's an understood exponent? So even though this is 6k, you can actually write it as 6k to the first, 6k to the first, 6k to the first. And then when we do this, k to the first and k squared, we're going to have 3 of them. Notice it stays k. Okay? This and this doesn't become kk, it just stays the same base. All I did was say 1k here plus 2 here, and that means all together is 3. And then any coefficients, there's a negative 6 here. Notice you don't see a coefficient there. You can slip in a 1 if that helps you. And then negative 6 times 1 is negative 6. And you're going to do that for each one of these. There's a k here, and it looks like another k here. So k, k, same base, so I keep it the letter k. 1 here, another one here. That means I have 2 of them. And then negative 6 times negative 11 is going to be a positive 66. Remember, negative times negative is positive. Anytime that you're doing multiplication, we use that tic-tac-toe board rules. And then here, now notice there's a k here, but no k here. So you have 1, but 0 here. That k is still technically here. 1 plus 0 is still 1. So make sure you bring over k. You don't have to write it to the first power because it's understood 1. If you're that person who likes to write in the 1, that's fine for right now. And then negative 6 times negative 3. We can multiply coefficients with coefficients, but we can also multiply coefficients with constants. So negative times negative, tic-tac-toe board tells us we're going to get a positive 18. Remember our tic-tac-toe board, just in case you forgot from the very beginning? Remember how I drew a tic-tac-toe board, pluses went diagonal, and then negatives everywhere else? So negative times a negative will give us a positive 18. Now once you get these 3 individual answers, you're going to have to see if we can collect any like terms. What are like terms? That's what we learned in section 5.5, adding and subtracting polynomials, which meant we had to see if we had like terms. Like terms, remember, has to have the same variable part. That is the letter and the exponent. So all of these have k's, but they don't all have the same exponent. So these are not like terms. So k cubed, k squared, and k to the first power, I cannot combine. To write my final answer, I always write it in descending order. Remember I said alphabetical first, well they're all k's, so I'm going to start with k. And then the highest exponent, or some people call it highest degree. So it's going to be minus 6k cubed. Now to separate this from the next part, notice this is positive. So if it's positive, you want to put a plus sign. Don't forget to put the plus. Because if you don't, then this looks all smushed together as one term. And I want to say that my answer has 1, 2, 3 parts or 3 terms. So we need the addition symbol to separate the part. And then this is a positive 18k. Now this method, you might be saying, well that's not bad. I kind of like the distributing method. If you like the distributing method, that's fine. The only problem with the distributing method is this. This was great when we had a monomial, remember that's one term, times a trinomial. They work best with distributing. But what happens if this isn't a monomial? We might have problems that might look like this. Negative 6k plus 7. Now how would you handle something like that with distributing? Well, you would distribute the negative 6k with this, the negative 6k with this, the negative 6k with this. But then you'll have to distribute this second term on its own. Positive 7 with this, positive 7 with this term, positive 7 with this term. And you might be saying, well, that didn't seem so bad. Now imagine if this was a trinomial. We might have trinomials times trinomials. If this was a trinomial, then just imagine this was this, this was this, this and this. Now you got to do the middle term. This was this, this was this, this was this. Now you got to do the last term. This was this, this was this, this was this. You're getting pretty long looking at this. And it's not organized because then you're going to have some like terms. So instead of using the distributive method for every problem, and we already said that we're not allowed to do FOIL for this guy because it wasn't a binomial times a binomial, let's introduce you to the method that I like the best. So I'll put the original problem that we had back up here. And I'm going to erase this. And I'll show you how this works, and then we'll talk about, in the next video, like binomials times binomials. So let me introduce this real quick. Multiplying polynomials. So when you are doing the rectangular method, what you're going to do is you're going to count the number of terms in each polynomial. Make sure you know if it's a binomial or a trinomial or has 4 terms. Because the reason why we need to know that, we're going to draw a rectangle. And a rectangle, we're going to put in columns and rows. So it's going to kind of look like a spreadsheet, you know, where you have columns and then rows going across. And that's going to be based on the number of terms in each polynomial. Once we have our squared or rectangle built, we're going to place our polynomials on the outside edges. We're going to have one on top and one to the left. It just depends on how they fit. Okay? So if you have a side that has multiple sides, then take the polynomial that has that many terms in it. Once you have that already set up, then we're going to fill in the individual squares. How do we fill in the individual squares? We use product rule, kind of like we talked about with the distributive. Remember, we kept the same base for the like terms, or for the like bases. We then add the exponents, and then finally we would multiply any coefficients and or constants. Once we fill in each of the squares, then the next step, we said collecting like terms. Remember how I told you they must have the same variable part? So when you collect them, remember, you keep the same variable part. Remember, variable part is the variable and the exponent. And then you're going to combine the coefficients, but this time we're going to use tug-of-war rules. Remember, back here for multiplying coefficients and constants, we use tic-tac-toe. But for combining, we use tug-of-war. And then here, we just said arrange your answer alphabetically with the exponents in descending order. Constant term will always be written last. So how do I write this as a rectangle method? Well, I told you, the first thing you want to do is count how many terms are in each of the polynomials. This one, we already said, is a mononomial. See how it has one term? This is a negative sign, not a subtraction sign, because it's not separating anything. So this is one term, and this, we already told you, is a trinomial. 1, 2, 3. Remember, these subtractions separate terms. So what I'm going to do is I'm going to draw a big rectangle. Okay? Now it's up to you on how you draw this rectangle. If you want to draw it tall or long, it's up to you. For some reason, I like to make them long this direction instead of tall. I don't know why. So whatever you want to do. So you draw a rectangle. Simple. Now we got to add rows and columns, okay? So, rows and columns. So one of them is going to be rows and the other is going to represent columns. Remember, rows go horizontally or left to right. Columns go up and down or vertically. So this is saying I draw one row, but I want to draw 3 columns. So how can I divide this into 1 row but 3 columns? Well, here's my 1 row. If this was 2 rows, then I would split it in half. And columns, since I need 3 columns, I'm going to put this into thirds. So here's a column, here's a column, here's a column. So you can see I have a rectangle that has 1 row, but 3 columns. Now some people ask, does this have to represent rows? Could this represent columns? You could. That's why I said you could draw it very tall. So if this was columns, you would only have 1 big column, but then you would have 3 rows. So it's up to you on how you do it. For some reason, I usually do this rows and this columns, but it's up to you. Once we have that, then what we told you to do is that we're going to place these polynomials on the outside edges. So this guy, because it's a mononomial, I'm not going to put it here because this is the space for 3. I'm going to put it on this side because there's 1 row. And this would be column headers. When I write them out, I include the signs. So this is going to be k squared, the first term. The second term negative 11k. And third term, negative 3. Notice they're on the outside edges. Once you do that, we said, we'll go back to this. Count the number of terms in polynomials, which we did, 1 versus 3. We drew our big rectangle, okay, based on rows and columns. And then we placed our polynomials on the outside edges. But let's get to here. Fill in the individual squares. We have 3 squares we need to fill in. So if we have like bases, we're going to use the product rule. Remember, keep that same like base and then just add the exponents. And then after you do the product rule, just multiply any constants or coefficients. So each one of these is a separate problem. So if you have k squared and k, they're the same base, k, k. So we were going to put the base k in here. We're just going to add the exponents. 2 here, and remember there's an understood 1 here. So 2 k's on top, 1 k to the left, that means I have 3 of them. And then to fill in for the constant slash coefficient, remember, coefficient negative 6, this one has a coefficient understood 1. So negative 6 times 1, negative 6. Remember, tic-tac-toe board for multiplication. Once you fill in one square, you go over to the next square. K, k, they're the same base, so the same ladder. Remember, there's understood 1 there. So notice we have 1k on top, 1k to the left. That means I have 2 k's. So I write as k squared. And what do I do with these? The coefficients you multiply. Negative times negative, we know we're going to get a positive 66. And finally here, there's nothing that matches base-wise, but that doesn't mean the k disappears. You still have to bring it over. There's no k's on top, but there's 1 here. If you still think of product rule, 0 plus 1 is still 1. It doesn't disappear. So make sure you put k to the first there. And then this is a coefficient, and this is a constant. What do we do with coefficients and constants? Multiply. Negative times negative means that we're going to get a positive 18. Now once I fill out the complete squares here, then we said our final step. Collect any like terms and write our answer in descending order with the constant term last. So let's take a look at our problem here and see if we have any like terms. Remember, they have to have the same variable part. Same variable and exponent. So notice, we're only collecting inside items. This, the outside items, you now can officially ignore. So I have a k cubed, k squared, k. When you look at all the variable parts, remember, it's the variable and the exponent. There's no match. So to write our final answer, we'll start with, they're all the same letters, so I don't have to worry about alphabet. Start with the highest exponent. Then go downhill, descending. So it's getting smaller. Make sure you had put this plus sign here to separate the k squared from the k cubed. And the same thing here, since this is positive, make sure you put a plus sign. And then we can put 18k to first. So this answer is the same as this. So it's up to you. If you like the distributing method, feel free to do that. Or if you like the rectangle method, feel free to do that. We're going to practice more on the rectangle because I like it when it's like a trinomial times a trinomial. You'll see why I prefer that method. And it works for any type. Okay? So we'll get to a new one in a second.